class. So today we will see unit number 4 of special technology. So this unit basically comprises of so let's go to plasticizers and softeners on page number 131. So blowing agents. What are blowing agents? Blowing agents are nothing but addition of gas molecules to polymers. So like polyurethane, polyurethane foams are used for making bedding, for making cushion, for making all seats. So you can see that the polyurethane foams are quite soft. When you sit on them you feel the cushion. So this is given to the polymer by adding gas molecules to it, and this is done by using blowing agents. So many polymers are used in the cellular form, in which the polymer matrix is filled with gas filled cells, which may or may not be intercommunicating. Over the years, many methods have been devised for producing cellular polymers, of which the most important are the following: incorporation of a chemical compound which decomposes at some stage of the processing operation to yield volatile reaction products. These are known as chemical blowing agent. So if you add a chemical compound, then it is a chemical blowing agent. Incorporation of low boiling liquids which volatilize during processing. Such volatile blowing agents are important with polystyrene and polyurethane and will be dealt with the appropriate chapters. Then diffusion of gases into the polymer under pressure, with subsequent expansion of the composition at elevated temperature after decompression. Such a process can be employed with a wide variety of polymers. Then incorporation of powdered solid carbon dioxide which volatilizes at elevated temperature. This process has been used in conjunction with PVC pastes. Chemical reaction of polymer intermediate during polymerization or cross-linking. This is also important with polyurethanes. Mechanical whipping of polymers in a liquid form and subsequent setting in the whipped state. The manufacture of latex rubber foam is best known example of this approach. Incorporation of hollow or expandable spheres or resin or of glass microballoons. Leaching out of soluble additives. Leaching is separation of solute from the solvent. In volume terms, annual production of cellular plastics products is of the same order of the non-cellular product, and it is not surprising that the mechanism of cell nucleation, growth and stabilization have been extensively studied. As a result of this, the texture and properties of cellular plastic can be widely controlled through such variables as average cell size distribution, including the possibility of some very large cells being present in the structure largely composed of small cells, degree of intercommunication between cells, and the use of non-cellular skin. Such variables are in turn controlled by processing conditions and by the use of cell nucleating agents and cell stabilizers in addition to blowing agents. A number of general comments may be made about chemical blowing agents. In addition to the requirement of common all additives, there are some special requirements. These include the need for gases to be involved within a narrow but clearly defined temperature range and in a controlled and reproducible manner. The decomposition temperature should be suitable for the polymer. For example, a decomposition temperature of a blowing agent system for PVC should not be above the maximum possible processing temperature that can be used if significant degradation is not to occur. Gases evolved should not corrode processing equipment. List many hundred of materials have been investigated at Boeing and the number in actual use is very small. Then cross-linking agent. In order to produce the thermoset plastic is that plastic which once taken the shape cannot be reshaped, or vulcanized rubber. The process of cross-linking has to occur. Vulcanization is a process of cross-linking because it makes the material very hard. Before cross-linking, the polymer may be substantially or completely linear, but contain active site for cross-linking. Such a situation occurs with natural rubber and other dyeing polymers, where the double bond and the adjacent alpha methylene group provide cross-linking site. So when the cross-linking is not done, usually the material is linear. But being linear, it also has some cross-linking sites in it. So double bond and the adjacent alpha methylene group. Methylene is CH2. Alternatively, the polymer may be small branched polymer, which cross-linking by intermolecular combination at the chain end. The term cross-linking agent is a very general one and covers molecules which bridge two polymer molecules during cross-linking. Figure 7.10a shows that molecules which initiate a cross-linking reaction. So you can see here, these are two growing polymer molecules and they are being linked, cross-linked. Then B, those which are purely catalytic interaction, this one. Then C, those which attack the main polymer chain to generate active sites, this one. And those which attack the main chain of the polymer to generate active site. So you can see A is the bridging agent, cross-linking initiators, C is the catalytic cross-linking agent, and active site generators. The first type include vulcanizing agents, bridging, such as sulfur, selenium, and sulfur monochloride for dyeing rubbers, formaldehyde for phenolics, diisocyanates for reaction with hydrogen atoms in polyesters and polyethers, and polyamines in fluoroelastomers and epoxide resins. Perhaps the most well-known cross-linking initiators are peroxides, which initiate the double bond polymerization type of cross-linking in unsaturated polyesters. Catalytic agents include acids for phenolic resins and aminoplastics, and certain amines in epoxides. Peroxides are very useful active site generators, abstracting protons from the polymer chain. With some polymers, this leads to scission, but in other cases, cross-linking occurs. Application of cross-linking agent to specific polymers are dealt with appropriate chapters. So here you can see, first is the bridging agent. In this bridging agents, these basically comprises of sulfur, selenium, and sulfur monochloride for dyeing rubbers, and formaldehyde for phenolics, and diisocyanates for reaction with hydrogen atoms in polyesters and polyethers, and polyamines in fluoroelastomers and epoxide resins. Perhaps the most well-known cross-linking initiators are peroxides. Then cross-linking initiators B part, these are peroxides. Benzoyl peroxide, for example, is a well-known initiator to initiate the polymerization. Then catalytic agents include acids for phenolic resin and aminoplastics and certain amine epoxides. Then this is the C part, catalytic cross-linking agent. Then finally, active site generator, peroxides, which are very useful active site generators, abstracting protons from the polymer chain. With some polymer leads to scission, but in some cases cross-linking occurs. So this is all regarding the cross-linking agents and blowing agents.